Imagine yourself as a developer who just joined a team that supports a large, complicated, and performance-sensitive app. As your first task on the job, your manager asks you to add a button to the header that opens a model dialog. Right there. You give it a try, code it, it works, but oops, it takes forever for the dialog to show up. At least a second. What is happening here, and how to fix it? Welcome to the Advanced React course, Episode 1. Today we are going to look at the most common performance problem in React, and in the process learn what are re-renders, how they begin and end, what is the biggest re-renders myth, why custom hooks can be dangerous, and how to solve our performance problem the easiest way. But first, let's look at the problem. Is it really that common? We have a large heavy app, we implemented a button, click on the button, opens the dialog, and it takes a second to open it. From the code perspective, it looks like this. Just an app component with lots of heavy components rendered inside. All that we did is we added some state for the future model, the button that flips the state from false to true, and the model itself that is rendered when the state is true. Most of us are probably writing code like this on a daily basis. So I would say it's a very common pattern. In this case, it happens to be very slow. Well, that's not a problem, we can fix it. But in order to do that, we need to first understand how React adds, updates, and removes components on the screen. For that, let's refresh our knowledge of React lifecycle. It all starts with mounting. This is when a component first comes to life. React creates this component's instance for the first time, initializes its state, runs its hooks, and appends elements to the DOM. Then there is unmounting. This is when React detects that the component is not needed anymore and gets rid of it, destroying the component's instance, its state, and all the DOM elements in the process. And finally, re-rendering. This is when React updates an already existing component with some new data. Compared to mounting, re-rendering is much faster. React just reuses everything that it can, like the component's instance, and updates already created DOM elements with new properties. Every re-render starts with the state. If a user clicks a button that triggers state update, the component that holds the state will re-render itself. After that, this update needs to be delivered to other components that depend on it. React does this recursively for every component nested in the parent component. If you imagine a typical React app as a tree, everything down from where the state update originated will be re-rendered. The component itself, its children, children of the children, and so on. From the code perspective, it means that when the state update is triggered here, the app component and everything inside it will re-render, including our very slow and complicated components. And here's your 1-second delay. The app needs to re-render everything before it can show the dialog. We're going to solve it in a minute. But let's quickly take a look at another danger when it comes to state-related re-renders: custom hooks. Hooks are great when we want to abstract away state-related logic. For example, we might want to move our model dialog state into a hook, to simplify the logic a bit and introduce a toggle function for convenience. Now, instead of triggering the state directly, it's hidden inside the hook. But it's still there. And every time we're clicking on the button, the state is updated. And a re-render of the component that holds this hook is triggered as a result. It doesn't even matter whether the state is used in the app, or even whether the hook returns anything. Let's imagine that inside this hook I introduce another state value. That one will change on window resize and will be used only internally by the hook itself. It doesn't matter. The app will still re-render on every state change inside this hook. And you will never be able to guess by the look at it. Essentially, a component with all its hooks behave as a single entity. An attempt to move state from a component into its hook will just make it invisible. But the app and re-renders will still behave as if the state is right there. By the way, have you noticed that I haven't mentioned props even once? There is this big myth that a lot of people believe in. that props change is a source of re-renders. It's amazing, really. Everyone believes it, no one doubts it, and it's just not true. Normal React behavior is that if a state update is triggered, React will re-render the component where the state originated from and all the components inside, regardless of their props. And if a re-render is not triggered, then changing props won't have any effect whatsoever. React doesn't monitor them outside of re-render cycle. If I use a local variable in props, for example, and try to change it on click, nothing will happen. The only time when props matter is when a component is wrapped in react.memo. But this is a completely different story and very complicated topic, so another time. Okay, now that it's clear how re-renders are happening and propagated through the app, it's time to actually fix the problem we started with. The solution is called moving state down, and it's ridiculously simple. All that we need to do is to isolate our state, regardless whether it's hidden in a hook or used directly, in a component down the render tree. In code, it looks like this. We take everything that uses our model state and move it to a smaller component, and then just render that component where the previous code used to be. Now, state update is still happening, but only the smaller component. The one that renders only the button and the dialog is affected. The big parent component that renders all of our expensive components doesn't have state anymore and never re-renders. Model dialog opens instantly now. This is just the beginning of re-renders story, by the way, and quite simplified as well. In the next video, we will look into how React actually triggers re-renders, discover that children are not always children, and take a look at another underestimated performance pattern.